Good morning, dear students. So as we have been doing the chapter on heat transfer, so let us continue from there. So in the previous class we have looked that whenever there is an increase in the temperature, it leads to expansion. And whenever there is decrease in temperature, it leads to something called as contraction. Yes. So this effect of temperature on expanding and contraction of solid, liquid or gases is termed together as thermal expansion. Thermal means related to temperature, and expansion, as you know what is expansion, thermal expansion. So in this video I'll be taking you through thermal expansion in case of solids. What happens whenever there is some thermal expansion in solid? So let us begin the discussion. So thermal expansion, I'll just write it. It is thermal expansion in solid. So a solid has a definite shape, right? So when solid is heated, it tries to expand in all directions. Yes. So if a solid increases, if a solid length increases on heating, this kind of expansion is known as something called as linear expansion. Linear expansion. So formal definition would be something like this. You can note it down. The increase in length of a solid due to heat is called as linear expansion. The increase in length of a solid is called linear expansion. So let us try to see how linear expansion depends on what. Okay, so why, meaning how does something affect the linear expansion? So linear expansion depends on, number one, something called as original length. Original length. And whenever we are discussing about expansion, linear expansion, we will always try to discuss it in relation with a rod, because a rod is a structure or a solid with which we can easily see how the length increases on heating. So original length of the rod. Yes. So if I have a longer rod and if I have a shorter rod, so if I start heating, then I can see that this will expand more compared to this one. Yes, so I can see that longer the rod, more will be the expansion, more will be the increase in the length of the rod. So original length matters whenever there is expansion. Another one is something called as increase in temperature. Increase in temperature. Increase in temperature. What does it mean is, if I'm heating a rod at say 5 degrees centigrade, and if I start heating the same rod at 10 degrees centigrade, then I will see that the temperature, pardon me, the rod at 10 degrees centigrade will expand more compared to the rod heated at 5 degrees centigrade. So I can say that more the temperature, more will be the expansion. So the last effect is visible due to something called as material of the rod. It is something called as material of the rod. So what happens in case of material of the rod is, so if I have a certain kind of material and if I have a rod made of another material, then I can see that it will be affected. Something like if I heat two rods of same length but one of copper and the other of iron at the same temperature, we find that the copper rod expands more than the iron rod. So this shows that expansion will depend on the material of the rod as well. Pardon me for that. So let me just write yes, thank you. So after this I have something called as, so let us try to understand what, meaning how does this material affect actually. So if I have something like L0 be the length of the rod at temperature 0 degree centigrade, and LT will is the length of the rod after heating it to T degree centigrade, then the difference, that is increase, is given by something called as LT minus L0 equals to L0 into alpha T. So this T is the temperature, alpha is something called as the coefficient of linear expansion. So let me just write it properly. It is called as coefficient of coefficient of linear expansion. So this is the discussion regarding linear expansion. Now let us move ahead to one more expansion, something called as let me just write it properly. It is known as superficial expansion. So what is superficial expansion is, just now we looked at the increase in the length of a rod or length of a solid. At times we can even have the increase in terms of area, right? So this superficial expansion is nothing but the increase in the area due to expansion. So let's see on what factors do this superficial expansion depend on. Superficial expansion basically depends on the following three factors. So first one is something called as initial area, initial area of the solid, initial area of the solid. So what it happens is, larger the initial area of the plate, more is the increase in its area on heating. If I have a dish something like this, and if I have something like this, then this will increase more compared to the smaller one. So this is how the area of a certain solid contributes to the expansion. Another one is increase in the temperature. As we have seen in case of linear expansion as well, whenever there is increase in temperature, there will be increase in the expansion as well. More the temperature, more will be the expansion. Again comes the third thing is material, material of the solid. If you see, a brass plate expands more than an iron plate of same dimensions for the same rise in temperature. Okay, so let's try to understand how this material contributes. So if I have A0 to be the area at 0 degree centigrade, A0 to be the area at 0 degree centigrade, and AT to be the area at T degree centigrade, then this is nothing but the increase is given by AT minus A0 equals A0 into beta of T. Now what is beta? Beta is nothing but the coefficient of superficial expansion. Coefficient of superficial expansion. So this is the discussion regarding superficial expansion, or the expansion in, or the increase in area. Now we'll try to look at cubical expansion. Cubical expansion. What happens in cubical expansion is nothing but the increase in. So we have looked at increase in length, increase in area. Now it should be the increase in volume. So cubical expansion is nothing but the increase in volume. So it depends on initial volume. So that means more the volume, more will be the increase in the expansion. And again, in the rise of temperature, more the rise, more will be the expansion. And another one is material again. So material, for material also we are going to do the same thing as in case of this one, as in case of linear and superficial. So what happens is, if V0 is the temperature at 0 degree centigrade, no, pardon, if V0 is the volume at 0 degree centigrade and Vt is the volume at T degree centigrade, then the increase is given by Vt minus V0 equals V0 into gamma T. Gamma is the coefficient of cubical expansion. So in this video, what we looked at? We looked at the expansion of solids, expansion of solids, expansion of solids. In this we looked at, first one was linear, second one was superficial, and the another one was cubical. And we looked at what are the factors that affects this expansion. So with this, I have concluded the topic of expansion of solids. Thank you all of you. Goodbye.